session, 31 sessions so far, almost 2 years, almost 3 years, almost. Um, so thank you for joining me. I have a lot of things to cover today. Hopefully we'll have time. Uh, we have time until 7. We'll see if we finish by 7 or maybe before. So first of all, do we have anyone new joining today? Raise your hand. There's this hand feature in Teams. Okay, welcome. Welcome, Edith. Welcome, Deepa. Um, Glad to have you here. We are recording that and uploading to YouTube, so you can watch if you're missing anything and you want to go back and have a recap. So it is part of our San Diego C Meetup channel. Um, let's start. I'll start by again thanking Qualcomm WRD software that I'm part of sponsoring the fees of this meetup. So thank you, Qualcomm, for that, for the support. I am looking for people to present and have a short or long talk. It's up to you. If you have anything that you would like to discuss, please feel free to approach me, and anything works, lightning talk or something that you had a chance to work on your daily job, or anything that you figured out and you want to share with others. We are here to learn. No one here is a huge expert. We're all learning here, that we want to feel that we are part of the community. The whole point of the meetup is to build community in San Diego, and obviously outside of San Diego. We have people outside of San Diego. So just feel free to approach me. There's so many things that we can discuss. We would never run out of topics in C++. It's the other way around. Every day there are more and more stuff that we discover. So it's a very dynamic language. It's a statically typed language, but very dynamic language, if you know what I mean. Okay, so the agenda for today. So we had the welcome slides, and we'll have few C++ quiz, kind of a tradition, and then 2 Stack Overflow questions that I had opportunity to review this month. Usually it kind of, I'm subscribed or kind of following Stack Overflow on Twitter, and I find a few of these questions that I say, okay, this is worth discussing, or I'll share it with others, and it might be kind of a niche type of domain in C++, or maybe something that very common and I want to discuss it. So it can be anything. So I have 2 today. Then we'll talk about a book on C++ 20. We'll talk about Sandor Dargo, that had a blog about find if that I found it very interesting. Sorry about the pun. And then I'll talk about a podcast session that I had the pleasure to listen to last week with Ivan Cukic. I don't know if I pronounce it. Kukic. I don't know how to pronounce it. So sorry about it. I really like this guy. He's an awesome speaker, and he has a great book that I'll talk about. Then some few Wallet Fox slides from the website, and then the last thing would be something that I blogged last week in Martin's blogs, and then I have link, and I'll talk about it briefly at the end of the session. Again, thank you, Qualcomm, for sponsoring that. We have a Dropbox where I upload after the session. I upload all the slides, decks, and we have a Slack channel. We have a Discord. If someone wants to manage these two, please let me know. I'll be more than happy to have people access to be admin and help me with that. I don't really have time to moderate. We have the YouTube channel that I upload the sessions, I do my best to do it at the same day, not always happening, but I do my best to do it. We have a Twitter handles SDCPP Meetup that I manage. My handle is Kobe_CA. Okay, so let's jump to the C++ quiz. So for that, what I'm going to do, I'm going to share my browser. Okay. So first thing. Okay, this is actually a very difficult one that I had no idea initially that this is how it works, but worth knowing about it. So take a look, take few seconds to look at it. So we have this integer I equal, and then we have ternary operation, or some people call it Elvis operator. And so we have this reference to an integer, a const reference to an integer. And then if I greater than 0, we pick I, other one will pick 1. And then we change to, and I is greater than 0. So this is picked, obviously. Then we have I equal to 2, we change I, and then we need to write here the results of the output, or there are a few other options. Either there is an output or compilation error, unspecified implementation defined, or it's undefined behavior. So what people think about this question? And it's difficult, so don't worry if you get it kind of wrong. I got it wrong initially. So first of all, the question is, okay, I is definitely 2, right? Everyone is agreeing on that. The question is A pointing to I or is A pointing to 1? That's the question, right? It's either 2, 2 or 2, 1. What do you think? Okay, so
it should be pointing to 1, no? Or like I itself, the variable.
it should be 1, you're
That's
saying.
right. Yeah.
Okay, so that's the answer. And the thing is, what happened here is that since one of these, like long story short, one of these are an R value. So these are actually not going to point. This I is not this const reference is not actually binding to I, but to a temporary of I. So by changing I to 2, you're not, A doesn't point to the same thing. It's actually pointing to a temporary. And the reason for that is the 1 here. So this expression is pure R value. It, in other words, is a temporary. The reference A is bound to that temporary and not to I itself. This is why I equal 2 ends up not modifying A. So A points to some other thing in the memory that is temporary. Otherwise, if it was pointing to the same memory, so changing I means that A would also be 2. So it would be 2, 2, but that's not the case. And this is why the difficulty is 3, because it's kind of a subtlety here. Because this whole the idea here is this whole expression is a pure R value and not something else. Okay, let's go to the next one. So the next one is question 120. Okay. So we have A equal 10, B equal 20, 2 integers. And then we have X. And then we have this expression with the comma. So X equal A, comma B. So what is X? obviously, it's a question about the comma part. So there are two options here, right? It's either x equal a comma b. So think about if I had a comma b in paren. So a comma b would be b, so x would be 20. Or it's an operator precedence. So what precede what is equal precede comma. So that's basically one of the key things that you need to, I don't know why they put it as easy. You need to remember how, like, what is the order, but do you remember what is the order? Basically, comma is one of the last one in if you look at the table, it's one of the last ones. So basically what happened is, first of all, x is assigned, a is assigned to x. So x gets a value, so it's 10. Then comma b. So the whole expression is 20, but x is assigned to 10, so it's gonna be 10. Just remember, don't do this, by the way. This is a very convoluted expression. Uh, have parent, just not confuse people and relying on people under memorizing the order of operators. So yeah, at least my
For
opinion.
this one, it's easy to remember the order, but if you think of the combining int x and the assignment, because we see
Oh, I
that
see.
often enough in
I
the
see.
code,
Yeah.
where we have int a equals b equals 2 and comma c equals 3.
Yes. 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 You're right. You're right. Yeah. Thank you. It's a good point. It's a good point. Okay. Next one. Okay. It's another easy one. We have this using func as an integer. I think we mentioned that once. And then func is f. And I think, Martin, I had this in one of the blogs that I posted some time back. So what do you think happening here? So we have an instant of s and then s dot f, and f is a function. It looks very weird. It looks like a data member, but is it a function? Because it could be a compilation error. This is basically a function. It looks very funky, but it is a function. It's an alias declaration for a function, and this is a function declaration, and here's the definition, and it's basically one. Looks very, very funky if you think about it. This func looks funky, but this is the syntax. I basically never seen such syntax being used as far as I remember, but maybe you've seen that in one of the code base or maybe books and okay. That's actually a very important one that shows kind of the order of construction and destruction. So we have this A, B, and C types. For each of the constructor and destructor is a print, either lowercase or uppercase. So the lowercase is on the construction and the uppercase is on the destruction. So if a global before main, then C, and then B. And this is supposed to be easy because this is like one of the basic stuff related to order of construction or order of destruction. So everything before main is constructed and then it would be destructed later. So usually what I do is for solving this kind of questions. So there is a construction of A and there will be somewhere at the end there's going to be a destruction of A, right? So we need to fill stuff in between here. Okay. Then we have C. So C would be constructed and eventually would be destructed. And then we have B. So B would be constructed and would be destructed. So A would be destructed last. C and then B. And construction would be A first, C second, B. And then when everything is winding down, B, C, and then A. It's a very kind of a very simple exercise about the order of construction and destruction. Just read that. It's pretty much saying everything. Okay. And this is such saying it's about translation unit. There is no guarantee between translation units, of course, which we know about it already. Okay, the last one is kind of interesting. What do you think about this one? What would be the value of?
It'll depend on the platform.
Depend on the platform. And this is true. And I would like, and this is okay. Let me go back and share my slides. Where is my? Okay, here it is. So I would encourage you all to go and watch this session from Dan Sachs. He is a great speaker, in my opinion. There is a very good one, choosing the right integer type in C and C++ from Dan Sachs, from Code Dive 2018. Talks about integer promotion and limits and what is standard, what is not. How about the whole int 8t, uint 16, uint 32, int 32, all of that stuff that are optional, they're not mandatory. All this stuff are part of the session. I think one of the um, well-spent sessions that I would recommend people to look at. Please do. Okay, so let's go back to a presentation mode. I'm gonna swap this. Okay. Hopefully you can see my presentation. Okay, so the next one would be a Stack Overflow question that I found it a bit not really, not about hard, but kind of interesting because I haven't thought about it. So there is a stud vector that is being initialized with another stud vector int. Now, as you probably can see, it looks very funky because the internal stud vector, I have pointer. The internal stud vector has an int in the template parameter, but the outer one doesn't have one. So the other one doesn't have one because it kind of relies on what we call CTAD, which is a class template argument detection. So basically, I'll talk about it in a second. But the question was, why? So the author of this question said, like, why I expect that to be a vector of vectors, and instead what I'm getting, so this auto is deduced to be a vector of integers. But the person that asking about that saying why it's not happening, like why CTAD doesn't, like this class template argument deduction doesn't deduce that this is basically a vector of int as the template parameter of the outer one, why it's not happening. And long story short, I have a link for that. Long story short, this is actually not really a CTAD thing. I'll talk about CTAD in a second because I think it's a good point just to mention that. What happened here is that it's basically the copy constructor is kicking in. So it is as if you were writing stud vector of int, like an empty vector instance of integers, so empty vector, and then you make a copy, you use the copy constructor, and then this is the instance that you have. So this is why you have that as a vector of integer and not a vector of vector of integers, like the bottom line. Now, So if you look at the there is a link in the slides. There are all kinds of mentioning about CTAD, and I thought that's a good thing kind of to mention, because it is something that I'm seeing in books and I'm seeing online, and I thought maybe this is a good point and a good time to kind of mention that. So as you probably know, there is a lot of class templates that you can write on, or the standard library has. There's a lot of them, right? There is a stud pair in this example coming from CPP reference. There is a stud pair, stud tuple, less, and so on and so forth. Think about vector that we just saw. There's a lot of class or struct type template types. So how come we are, since C++ 17, we can have this style where we can omit this angle brackets and just have stud pair p2 and 4.5, and it is that used to be a pair of integer and double. Same deal for tuple. We have an integer and a double. Like how's that possible? We used to have these helper functions to help us deduce with stud make tuple and similar. Here's studless, by the way, which is void. How come this is actually possible? So since C++ 17, there is something called class template argument deduction, which is CTAD, and it's basically. Let me show you a few examples. Take a look at this specific class that I would like. This is my class, and I have this constructor that accept this t and initialize some internal variable and internal data member, and I don't need to say foo of int. It just knows that it is an int. I omitted the angle brackets. So how does it work? There is a very good article, a blog post from Marius, which is he's a great, again, a great author. He has a few books that I mentioned at least a few times during this the past couple of years plus. So you can think about it where the compiler is actually encountering this kind of a declaration. It builds all, like implicitly build all kinds of candidates and pick the correct one, and figuring out that this is the type that that should be used as a template. Now the question is, so here's how it's going to look like. The question is, what if I want to help the compiler? And there is a way to, and the article has a few examples. There's a lot of, the next slide I kind of collected a lot of good articles from the net that I used to read back then, and recommending you to look at. So there is a way for me to have CTAD kind of guidance deduction for the compiler, kind of hinting the compiler, look, if I have this, if I put this hello, I can have this syntax. It looks pretty funky, but I have this. Okay, if it is a const car pointer, I want you to deduce that as being a stud string. So hello would be a stud string, and then t would be a stud string that is initialized with some literal, with some string literal. So I can, and this is how it looks like if I basically instantiate that. So this is from CPP Insight. It's a website that I've showed a lot of time. It's very insightful, obviously, to see how things look like from the compiler perspective. Okay, so that was about CTAD. I don't know if people are using it a lot, but it is being used extensively in many places. I see people recommending don't use stud lock or with the actual mutex. Just let the compiler deduce it, and don't use stud pair with the angle bracket. Let the compiler do that for you, and so on and so forth. So it's really up to people. They like it. Some people they don't like it. So the people that, by the way, that don't really like it, they think that it's something that should that is a template, the syntax should not be confusing. And okay, stud pair, everyone knows that it's a template, so maybe it's okay, maybe. But think about a code base that you don't know if it's a template or not, and now you need to understand that this is a template. I think IDEs like CLion and similar, if they have this whole annotation and hints, that helps, but not everyone is using this sophisticated IDs. So it's really up to you. It's kind of like, should we always use auto or not? It's kind of the same level of, maybe the auto is a bit more hectic in terms of the discussion. Okay, the next Stack Overflow was actually very surprising for me. I don't know if others, but take a look at, this is a kind of a today I learned kind of a thing. Not today, but few weeks ago when I was preparing this agenda for today, and I saw that in my Twitter feed. I don't know if anyone else had a chance to look at it, but here's the question. So you can see that there is a template function. This auto is basically a template function. It's a C++ 20 plus, and eventually all compilers accept that. It means that, so if you remember, the return type is not part of the signature, so you can't really overload on return type, but apparently it works with templates. And obviously this is something that is part of the standard. I didn't know that. And this is actually what helps us to write things like Sphina. I'm not gonna talk about Sphina right now. It's too much work. But I think I mentioned it at least once, at least internally in Qualcomm. So the idea is that in Sphina, we have all kinds of enable if that are, so you can see that there is exclamation mark here, that we can change the type and not overload, but basically have a different behavior based on the return type. And this is why with templates it's actually required. So this is something that I wasn't aware of, that you can actually do this with a kind of overload, have the same signature but different return type. Anyone actually knew about that? No? So I'm not the only one? Okay. Take a look at the Stack Overflow. I have link in the slide, and so feel free to look at it. It's pretty interesting.
How is that example valid?
This one?
Because the parameter is going to be different as well. It's not just the return type.
Yes. What do you mean the parameter is going to be different?
Well, one is going to take an integral reference, while the other one is taking a non-integral reference. They are not different. Key is going to be different when the template is instantiated. So the parameter is going to be different.
I agree. It's different when it's instantiated. Actually, one of them would not be instantiated, right?
Yeah, I mean, depending on your type, you will have one or the other, but
you have one
the
or the
end
other.
result
Yeah.
is a symbol with different parameters.
Yeah. So basically, the way I see it is that I agree that basically at the end, at the instantiation point, you're not going to end up with two of them. Actually, here he ended up with two. So so if you look at the Godbolt, he actually ended up with two, and one of them was picked. I think Clang, one of them was not. So Clang and GCC didn't agree on some of the results, but I agree that this is at the end of at the instantiation point, you're not going to end up with two functions with the same T reference and the same return type. But I think what this person is trying to say is that this : type, or the whole expression is kind of similar. I think that's the point of the solution. Not solution, but the answer. But I agree that you're right that the instantiation point is different.
So actually, in the previous in the other example, what really matters is the fact we have auto as a parameter.
Yeah, exactly.
That's what makes it work. If auto
Yeah.
was removed or if it was a fixed type, then you wouldn't be able to define those
Right.
two functions.
Exactly. Yes, I agree. Yeah. Okay. The next thing is a book that I would like to recommend. It's a very, I think it's well written. It's about C++ 20. I have a copy of this book that I'm looking at it from time to time, and it has basically all the ingredients for a good book about C++ 20. It talks about the new stuff on 20. By the way, there is no, I wouldn't say completely no, but I think Justice and some other people, they do have books that they have a very thorough C++ 20, but from Apress, I think maybe the clean C++ 20 has a very good C++, like more in depth, but some of them are just giving you the basics of the new C++ 20 stuff, like the ranges and modules and concepts and things like that. But it's still a very good introduction. It is written in a modern C++ syntax, which I really liked. I did, by the way, when I was preparing the slide and I was kind of flipping through the pages, I found this, which kind of was interesting. So you see this uh, constructor. So this is from page 236, and I reported it to Apress about this error. So you see this constructor, and there is this. This is a copy from the. So I have the ebook also. So you can see that it says initialized x to 1 here and y to 0, which is not correct unless you have an instance of point in the global as a global instance. Then, or static instance. Then yes, it's a 0 initialized, but to say that y is 0, this is not correct. The way it's written right now, this is not correct. I'm not talking about point, p, and then curly braces. That's something else. Um, the, y is kind of uninitialized unless, again, it's in static or it's a global namespace. So that's one thing that I found that was kind of an error, and I reported that to Apress. The next thing I wanted to talk about a blog post from Sandor Dargo, and I found it very interesting because I always reached out to find if I wanted to see if something exists in a container, can be a vector array, set, doesn't really matter. But the interesting part is that sometimes what we want to see or what we want to check is, do we have anything or we have none of these? So we usually run find or find if. Find if it has a predicate. Find just have maybe a value that is compared. So sometimes we just get the iterate. So find and find if returns an iterator, and you usually, in order to see, oh, I found something, I'm going to compare it with end, either std end or the containers end member function, and then it's basically a true, false, yes, no kind of a question answer. But and you don't really need if you found it, you don't really need the value. Just want to see if it's there. So what he was saying is that there are 3 algorithms that worth looking at: any of, none of, and all of, that worth looking at if you just want to, and it proves readability because it returns Boolean. And you don't need access to the element. If you found the element, you don't really need that. You just need a yes, no, found it, didn't find it, true, false, all of that kind of Boolean answer. And I found it very interesting approach because I haven't thought about using all this. I know I'm using these functions when needed, but I didn't think that it's actually a very cool idea just to use it because it's more readable. You don't need to kind of check against and it just gives you a boolean and you're done. So any of would be if you anything is you have a predicate. If anything works, it stops and returns true. None of needs to scan maximum everything, or if it found something, so it stops. All of needs to have, let's say, all of and the predicate that needs to be true, so it checks if all of them are true. If one is for example false, it would stop. So I would suggest you reach out to these algorithms. Check his blog. He has a very nice GitHub page about a lot of CPP resources. I found it very nice. Like there's a lot of things out there in this page. So take a look. There's like blogs and videos and books and whatnot. So podcasts. There's a lot of things. So if you thinking about where can I find resources, there's a lot of similar uh, uh, pages, but this is really comprehensive. So take a look at that. And the last thing, Sandor has 3 books in LeanPub. One is the Daily C++ Interview. It's a bunch of small questions about C++ that and answers. A very nice collection. He has a book about C++ concepts and how to use const in C++. The fact that we need a book about how to use const in C++, it's kind of amazing in my opinion, but it's all 3 of them are really nice to kind of own there. I don't think they cost a lot of money. I can't remember exactly. And the next one is I want to share with you, there is a functional programming podcast, Functional Geekery, and episode 130. It's actually an old one. It's April 28, I can see, from Ivan. And Ivan he's a great speaker, by the way. And I found this specific episode very kind of inspiring. It talks about C++ and functional programming in the context of C++, ranges, lambdas. Also, there's a lot of there's a lot of points about having Rust in the mix. Ivan has an opinion. I actually found it very interesting because Rust is something that people talk about a lot. And the thing with Rust that Ivan said, kind of not related to C++, but Rust is really good in terms of the whole bound checker and all. But when you try to do some more stuff, you need to reach into the unsafe parts of the language. And C++ gives you ability to do everything. And this is why I even really like C++. And talks about Haskell and all. I really like this episode. It's a 1 hour, very good one if you have time when you walk the dog or something like that. Yes, so this is the functional programming in C++, and he has a book. I think I mentioned that in the early days of our meetup. I think one of the best books probably in C++. I know I said about a lot of books, but this is really a good functional programming. When I picked it, it was before I actually had a chance to look at ranges, and I was very surprised to see that ranges is part of the book. So, yeah, if you don't have it, this is my opinion a must. Okay, so we do have time for some Wallet Fox slides. So let's say we want, this is actually a very nice one with ranges. Let's say we have a number and we want to, it's a binary and we want to transform that to a decimal. So 1110, so it's to the power of 0 and then plus to the power of 1 and so on and so forth. Well, here's how he is doing that with ranges. And just a reminder, WorldFox has a booklet of ranges that I highly recommend. There is a second edition. If you don't find it, just ping me either in email, LinkedIn, Meetup website, and I'll point you to the booklet. You can purchase the ebook of this booklet, or you can have the actual soft cover or the physical one. So anyway, here's a nice way to do it. So you have this. It's basically initializing a list of unsigned integers. So 1, 1, 1, and 0. So this is what we actually want to transform, right? We want to have 14. So first of all, we reverse it. So we have, v view reverse, we have a view, nothing happened. We just have a view that's going to be reverse. So we'll start with 0, because this is the first one. We want to do 2 to the power of 0 and 2 to the power of 1, and so on and so forth. Then what we want to do is generate 1, 2, 4, and 8. So we want to have 0, 1, sorry. We want to have, 1, 2, 4, and 8. And we want to basically multiply that. So 1, this is 2, and this is 1, this is 2, and this is 4, and this is 8, right? So this is what we want to have that will be the power of. And then we want to just multiply, and the multiply is the inner product. So we have two views. One is going to generate something, and there is a mutable here because we actually starting with 1 and increasing. So 2 to the power of 0 is 1, and then times 0, and then so on and so forth. Then we take these two views and we inner product both of them, starting with 0. And that's what we get. We get 0 times 1. By the way, there is so this 0, I think, would be the plus 0, which is not shown here. So 0 times 1, and then 1 here times 2, and then 1 here times 4, and 1 here times 8. And if we had more, this view would generate as many as we need, and then the inner product just multiply all of them and sum everything with the initial value of 0. Okay, functional programming in C++ 14 and 17. Actually, I think we mentioned something very similar in the past. So we have this function. It's a lambda. It's a specific function that returns a function. So this is a very kind of a functional programming. Functions are first-class citizens. You can pass function as a argument to some parameter. You can return that as a return type of a function. So here what happened is that we have a function that, and auto means it's a template. It's a template lambda. So, but it doesn't really matter for now. We have a x that is being passed, and we are using equal sign, which means we are making a copy. And we're returning a lambda, a new function that has a data member of x that was copied. The other side has the same thing, but instead of having a copy of x, we have a reference to something that is passed to us as a parameter, right? So this is a parameter, and when we return the lambda, this one dies. We have a reference that just dies. And when we try to now pass something to y, this is 2 goes to y. 2 times 7 prints 14 here because we have a copy. X is valid. Sorry, 2 is the x one, 7 is the y. So 2 here, x is being copied. Here 2 is some value, temporary value, or kind of something that we cannot reference. The lifetime goes away when this expression is done, and f7, which is f is basically the function we got back from multiply, and we pass 7, and it kind of prints gibberish on. By the way, you can try it. You get all kind of very funny results. So yeah, so make sure that when you use references in Lambda, you make sure that whatever you reference still alive. It outlived the Lambda. And otherwise, if it dies and the Lambda is alive, it's pointing to something that is dangling. Okay, something that I really didn't know, actually didn't pay attention, is that let's say you have an object, a type that has two functions. One is a const function and one is not a const function. And you assign this instance to a stud function, even if it's a const, versus you assign it to some auto basically just deduce that it's just an f object. And then you invoke it. Here it's going to invoke the const function. Here the const function is not going to be used. Obviously, what it says here in yellow is that if you only have a const function, it's going to be invoked. But if you have two of them, it's not going to pick the const object, which is something I wasn't aware of. Even if this is being const, when you call f, it's not picking the const function. Okay, we are done with this part. Any question or anything like this before we go to the next thing? Any comments people want to make? Okay, so the next one, I'm going to okay, hopefully you can see that. This is something that I exhibiting in many code bases, and I thought this is going to be an interesting thing to share with others. So I had that posted in Martin Vorbord blog a few days ago. By the way, I obviously recommend you to go and take a look. There's a lot of blog posts from Martin, very useful one that I learned a lot from. So so please do and subscribe and feel free to browse it. There's tons of stuff there. So so I was looking at many code bases in my life, and I recently bumped into something that was kind of a reoccurring, and I've seen that in multiple code bases, and I thought this is all. It's a very kind of a trivial thing, but I see that people actually using something that might be improved, could be improved. So this is why I wrote the blog post, and I also had a few slide decks that I would like to share with you. Okay. So again, this is from the blog post. Feel free to go back and take a look at that. There is a GitHub that you can go and check it out, the code, and play with it. The reason there is 61% of C++ and 33 is because the Conan file, the Conan file is as big as the C++ one, but yeah, don't worry about it. Okay, so here's the use case. Let's say you have a struct or a class, doesn't really matter, and you have a lot of things, a lot of data members, and you have also an ID. Okay, and the ID is unique, and you need this, you have this requirement that where you want to have that placed in a map. It could be, by the way, an unordered map, but the specific use case that I'm talking about just happen to have a map. I'm already kind of jumping ahead and say that there is a very good comment from Martin in the blog post itself that you should go and check it out. There's all kinds of more ideas and more improvements. So, but let's say there is a map, and the map is from an integer, from an ID to the object itself. It's the same ID of the object. So the object itself has the ID. And there are lots of helper functions to get the map and insert an object. So here's an object. So the function would take the ID. I have everything as public. It's a struct, but think about there is an ID member function that you use in order to get the ID and put it in the pair as the key of the map. So and this is just an example how to use it. There is a map, and I using structural binding to get the ID and the object and just print. And basically the ID and the object.id would be the same. So there are all kinds of requirements. We want to, when I have a map, I want to access the object by an ID. Obviously, if there is no such thing and all, I can check for errors, but for simplicity, I'm not showing this in the slide. What do we pay here? Like, what is the extra cost that we have by using this method? Again, I've seen that in many cases. So when you have such object, which is a string and an integer, the total pair is 48. So pair is basically taking the ID and the object. The total pair is 48. The object itself is 40. The string is 32. So basically, we have an integer of 8, and we add another 8 on top of that for the integer inside the pair. So the question is, why having this duplication? Why having the ID outside? Yes, you want to order that. You want to have a search. You want to log in by the ID, but you actually paying an additional 8 bytes, and you have a very big set of data in your map. It adds up. And if we want to talk about minimizing footprints and all, we should think about, can we do it better? And the idea is that there is already something specifically for this use case. We can actually use set. Set has the same properties, minus a kind of minus the subscript operator. We'll talk about it in a second, but it's very, very similar to what map has. It most likely implemented the same, but instead of pair, it's basically just there is one key, which is the object itself, right? So we can actually put the object inside a set and have the exact same behavior, and I'll explain. We can go and iterate, we can find. So this find is basically replacing the subscript operator. But semantically speaking, we have the same semantic. We can access an object by having the ID. We save 8 bytes per record, which is really, really cool. Like when we talk about a large number of values, this is gonna adds up. But do we get it for free? Not free in terms of runtime, but if you remember, when we have stud map that has an integer map to as a key, map to an object, we didn't need to do anything. The compiler I could insert an ID and an object, a constructed object, and there are multiple ways to do that, by the way, like in placing and all. But I didn't need to do something special. The compiler knows how to, because they are ordered by the ID, right? It's a red black tree, and it's ordered by, think about the binary search tree, and it's ordered by ID. So the compiler knows how to compare integers. It's not a big deal for the compiler. But what about set? When we set basically is a template. When I put object, I have some of the other template parameters as default, like the compare template parameter is defaulted to a stud less of key, and there is an allocator. We're not talking about allocator right now, and forget about the PMR right now. PMR, it's the polymorphic memory resource. Forget about it for a second. So yeah, so sets are usually implemented as red black trees. So what do we need to do in additional in order to make it to work? Like if you try to just have this object, this specific object, and place it in set and start inserting stuff, you'll see that there's going to be an error saying, I don't know how to compare an object to another object. Like the compiler needs to, eventually the compiler needs to use a less than operator on two objects. It doesn't know how to do that. So we need to teach the compiler how to do that. And it's not a big deal. You can do it in multiple ways. So this is one way to do it. And again, take a look at what Martin had as a comment in the blog post itself. There is also a way to do it with Lambda and other at least two more ways to do it. But most of the people would be very familiar with what I'm showing right now, which is basically overloading an operator less than for an object. So when I have two objects that I want to compare, this is what basically std_less would do. The parent or the callable operator of std_less would call this operator because they're comparing two objects. So one would be the left-hand side of the operator, and the other one would be the right-hand side. And once I provide the compiler a way to compare these two, because std_less has a function that would call it, so that would be resolved, then everything works pretty well. So this is what I was talking about. Std_less would be a std_less of object, which we be looking for this operator, this less than operator. And it looks like this. So this is how this is a print screen from C-line. You can see that this struct less, let's forget about the binary function. Binary function is basically deprecated in C++11. It's kind of removed in 17. It is removed in 17, at least CPP reference saying that, but it's still there in my code. This is, if I'm not mistaken, a libstud C++ that is shipped with GCC 10 on my WSL 1.0 machine. So it's there, but forget about that. There is an operator, callable operator, like parent operator with two, it's a binary function and just compare. So this object less than object would be invoking this object that this less than operator that I mentioned. So how about searching? So I mentioned that we don't have the subscript operator. Instead, we have this find, and I'm not showing here error handling, just I'm not showing in the subscript operator. But there is another wrinkle here that we need to kind of solve. Find, basically, if you look at the signature of find is looking for an object because I have a stud set, so I have a set of objects. I don't have a set of integers. And if I want to say, okay, give me 5, give me the object that corresponds to 5, I need to create an object and pass it to find. So there are a few ways to do it. One way, which I found it like the most kind of straightforward way to do it, is to create a conversion constructor, which is this, what you can see here. So take a look at the comment that I have here. We cannot make it explicit because if we make it explicit, this expression would not work. What happens here when we have a conversion constructor and we pass an integer? In this specific case, the compiler would say, I need an object. Do I have a constructor that can take an integer and construct an object for me? And if this constructor is implicit, i.e. it's not marked explicit, I would use it. I, as the compiler, would use it. I'll create a temporary form for you. And this, by the way, could be optimized very well. You can benchmark and test it. But basically, there's going to be a conversion to an object. And now once I have an object, the find function is satisfied and I can go and use it. When I say I'm talking about the compiler, can use it in order to compile the expression. If you still want to have explicit, you can always say, okay, give me find of the object and then the arguments. That's and that's an option, but I found it very convenient not to have it marked as explicit. Obviously, there are other ways to do it. You can have an explicit and make it a private, and then have a function that is wrapping fine that this function is a friend. There's all kinds of hoops and loops that you can go through, but I just didn't feel like it's worth pursuing. Though you can have that happen. If you have other options, yeah, feel free to bring it up. You can put it in the comment of the blog itself. Again, as I mentioned, the GitHub repo is mentioned in the slide deck, and basically this is the end of what I had for today. Which we finished everything in 1 hour, which is pretty nice. Any questions?
Yeah, I had a question. I'm actually finding myself in my current code base using unordered maps, and it's using a string as the ID because I have an object as the value, and that object has the ID that I'm looking for. So this is actually pretty relevant. But I'm wondering, you meant this is all related to just tree maps essentially, as opposed to unordered maps. So in my case where I have unordered maps, what function would I need to implement? Is it just like the hashing function, or?
Let's take a look. Let's take a look. What it might be a hashing function, but I can't remember. Let's take a look. Let me open CPP reference. 1 second. This is what you need to, the equal to. So hash is one of them. So whatever, if there is already stud string, if there is already implementation of stud hash, which you probably have because otherwise you would need to do it anyway. But this is this equal to, which is, let's see what, so equal to is actually doing equal. So this is what you need to make sure that there is an between your objects. So this is this is what is being actually eventually possible implementation. Probably that's what we have. Usually that's what you see, and it's completely equality. It's not equivalence, but equality.
So if I wanted to convert my unordered map to an unordered set,
Order set, it would be equality. Yeah, it's the equal to. Yeah.
and then I guess that's what it would find when I'm using .find or find if. Things.
Yeah.
Okay. It's just that I'm thinking now. I think it's actually my key was a stud string, but my the thing that I'm comparing it to is a character buffer. So I think it's just a little bit different there, but I don't think that should be too much of an issue.
Yeah. You can try optimizing it and then remove the duplication.
Right. Interesting.
Yeah, I'm glad that you pointing that out because it's a very valid scenario as well. Let us know next time, by the way, if it went well, if you have any other insights that you want to share with us. Just remind me next time.
Yeah, sure.
Thanks, Mo. Anything else people want to share? No. Okay. So thank you so much for joining me, and we'll see you next time. Take care.
Thanks.
Thanks, Kobe.
Yeah.
Thank you. Bye-bye.